So what you just saw Adam present was how to eject a project created with Create React Native app to just a bare bones iOS and Android project with React Native embedded, and then how to link in an NPM package that has native code as a part of its implementation. But what if you want to write your own native code? This is something that is very common if you have your own custom native modules already on your, in your already existing iOS and Android apps, or if there is a third-party component that has native code that you would like to fork and modify. You also need to be able to test it. So we're going to go through some of the requirements and the design around the React Native native module system. We won't actually go into writing one of these because a lot of that is already covered in the React Native docs in quite some detail. And instead, I'd like to share with you some of the high-level thinking behind the native module system and also some of the gotchas. So to begin with, why would we want to write a native module at all? Why don't we just write only JavaScript? And the answer is generally when there's something that you want to do in your app that you can't do with just JavaScript, you want to write native code. Generally, it's nice to be able to write only JavaScript. Brent actually has a blog post on Medium about why you should try to write JavaScript with React Native when possible, but sometimes you just need to expose native functionality. And there are two types of native modules. One is a native view manager, and this is for rendering native views such as the Maps component. So on iOS, that's Apple Maps, or if you have the Google native plugin, it can be Google Maps, and on Android, that's generally Google Maps. Also, a lot of the views that you've been using, in fact, almost all of the views that you've been using over the past 2 days, such as view, scroll view, the slider component, text field, those are all actually implemented using the exact same system that you would use to write your own native views. The other class of native modules is non-view native functionality. This is something like Bluetooth, for instance, or geolocation, device orientation, being able to lock whether your screen rotates when you rotate your device. The list goes on. Audio is another example, flashlight, vibration. There's no view component associated with this native functionality, but you still can expose it from native to JavaScript. The way you do this is I highly recommend starting with the React Native documentation. There are in-depth guides on how to do both view managers and headless or non-view native modules, and they explain a lot of the details around how to do this. I recommend starting with a very small example. Some of the implementation details are very finicky, so I would recommend just copying and pasting like the smallest examples possible and just trying to add little bits of code until you have a native module working in your application, and then going from there and adding more complexity. The docs cover both platforms, so if you have an Android and an iOS app, you should be good there. The APIs for both platforms, however, are slightly different, and the APIs for view managers and non-view modules are also different, so be sure to read the docs carefully. Some of the details around implementing native modules is how the calls go back and forth from JavaScript to native and also native to JavaScript. The concurrency model is also important to have a basic understanding of, but generally it's not something you have to worry about too much. And then I'll end with some advice around implementing native modules. When you want to call into native functionality from JavaScript, you will define natively implemented methods that automatically declare corresponding functions in JavaScript. This is covered in the React Native docs that I mentioned. You know you're looking at the right place if on iOS you see this RCT export method macro, and on Android you see this @React method annotation. And it's pretty straightforward. You implement a standard Objective-C method on iOS and a standard Java method on Android. You're given a promise-like API with resolve and reject functions that you may be familiar with if you've implemented your own promises in JavaScript. And that's how you get results back from the native side to JavaScript. The promise API is also kind of nice because when you use it on the native side, it automatically declares an ES2017 async function on the JavaScript side, so you can await these functions as well. One thing to keep in mind is when you implement these native methods, they can send only one result back. For example, if you're implementing a geolocation component and you want to get the user's current location, in your native implementation, once you get their location using the native iOS and Android APIs, you can only send that current location back to the JavaScript side. You can't send a stream of events as the location changes, for instance. This is something that trips up a lot of people because you're given these native callbacks in iOS and Android, and if you try to invoke them more than once, you'll encounter strange errors. So if you want to send back a stream of values from native to JavaScript, then what you do is use events. So events are the mechanism by which you can send information to JavaScript from native. On iOS, you want to look for a class called RCT event emitter. On Android, you'll want to get access to the RCT device event emitter instance. I'm not going into detail about how to do this stuff, but rather sharing with you some pointers so that you know what to search on Google for, or in the React Native source code. It's very helpful to look for RCT event emitter or RCT device event emitter, because you can look at how a lot of the core modules in React Native are implemented to learn how to write your own native modules, because the techniques are exactly the same. And because the APIs on iOS and Android are sometimes slightly different, I recommend writing a JavaScript module that abstracts over these platform differences. So your JavaScript module will have some code that looks like, if the current platform is iOS, use the iOS event emitter API. Otherwise, on Android, use the Android event emitter API. And then from the rest of your application code in JavaScript, you just call one consistent interface. The concurrency model of the native modules is it's designed to take advantage of the fact that many mobile devices are multi-core. Each module, by default, runs on its own GCD. This is Grand Central Dispatch, the iOS concurrency system, GCDQ, or on Android, its own thread. And this is great, because if your phone has at least 2 cores, then while the main thread is doing some actual rendering work, or the JS thread is processing your JavaScript, your native modules are efficiently utilizing the other half of the hardware and not blocking your UI or JavaScript work. On iOS, you can specify which GCDQ you want to use, and this is important, for example, for native modules that use UI functionality, because there is this restriction on iOS that a lot of UI classes need to be accessed on the main queue. And then on Android, you have to manage the threads and the runnables yourself. You would write code to dispatch some, like a Java, basically a closure, to run on the main thread. Again, I recommend looking at the native modules inside of the React Native repo itself. That's all open source, to learn how different native modules are implemented. Some miscellaneous advice for native modules is keep your state inside of your instance variables. You want to avoid statics. The reason for this is every time you reload your React Native application, as you've done many, many times for the past 2 days, like every time you made a code change and your app reloaded all the code, it actually reloaded not just the JavaScript, but created new instances of all of your native modules. So that state in a previous run of your application is not persisted in a new run of your application, so that you can get a fresh copy of your app. But for this to work, a lot of your application state needs to be stored in instance variables, so that when you reload the app and the old native modules are destroyed, and the new ones are created, that the new ones don't have any old state carrying over. I also recommend thinking of your native APIs as a combination of the native and JS code, actually. The reason for this is sometimes it's easier to implement a different API on iOS than on Android. But then when you want to call into that API, you want to have a consistent interface. So if you think of your native API that you're trying to build for your teammates or for yourself as a combination of the native and JS code, then you can have one implementation for iOS that's slightly different from the Android implementation that's abstracted over with a consistent JavaScript interface. I kind of mentioned the promise API earlier. When you use the resolve and reject APIs on the native side, that defines for you a JavaScript function, JavaScript async function, with which you can use the await keyword. So that's very nice. If you've used that before in JavaScript, you know how nice this can be compared to a bunch of nested callbacks in many cases. And lastly, this is quite specific, but sometimes you want to implement a view that not just has props, but also has imperative methods that you can call on it using the React Ref API. This is something that in the React DOM world, sometimes we have, right? Like you get the ref of a component, and then you can call imperative methods on it. This is a little bit tricky to implement in React Native. If you never encounter it, that's great, but just as a high-level strategy, the way to do this is to implement both a view module and a non-view module, and then in JavaScript abstract over both with a consistent component that wraps the view and the imperative non-view API. So that's the high-level kind of guidance around native modules. Again, the docs cover a lot of the specifics. I just want to share some of the high-level advice. I'll also post these slides in the Slack channel so that you have them for reference if you do go embark down this path. And that's all. Thanks.